Hi everyone, I'm really excited to be here. So, like Monty Python used to say, now for something completely different. A bit about myself. This is what I studied in university. Nothing related to computer science whatsoever. And I'm working in a company called Epsilon. I'm going to talk about her in a few minutes. But when my boss found out, which is the CEO of Epsilon, it was like this. That's not him, by the way. So there's this whole notion of when you're doing high performance stuff and in computer science, like know all the bits, all the bytes, big O notation, complexity, data structure, and everything. And I come from a kind of a different world, but luckily for us, this is where I work. I'm working in a company called Epsilon. It's an Israeli company. We're doing mobile attribution measurement, and we're handling a lot of incoming data points, around 80 to 90 billion events per day. That's what we're processing. And when I joined Epsilon, when my boss was horrendous in his reaction, it was just him, the CTO and co-founder, and myself as the first employee. So this was the R&D, 2 people. And now we've grown a bit. And this is the numbers currently. And again, they're interesting in their own right, but what's really interesting is, again, it's a company that deals with massive amounts of data, and most of the backend in the Epsilon is within an enclosure. And I think as we started writing in Clojure around 7 years ago, the idioms of the language and the choice of doing something in Lisp or in a Lisp mentality really resonate with both me and the CTO. And as we grew older and we bootstrapped more and more developers, currently there are around 250 people in Epsilon R&D. Around 150 of those are doing Clojure on their day-to-day job. And what I'm trying, and my main job today is helping them be better. And I'm always trying to do both the low-level stuff and also talk a bit about the approach, what you gain and what you lose when you choose some idiom or some programming language and stuff like that. So most of my connotations come from what I studied, what did I study? Let's see again. So I studied English literature, which is text analysis with language tools, and I studied cinematography, which is text analysis, and text is a really, really broad term. It means everything that you can analyze with language tools. So if a text of a book is the actual words on the paper, the text of cinematography is mise-en-scène, placement of actors in a scene, camera angles, white balance, and stuff like that. I studied Latin, which is philology, which is the study of languages, and I studied philosophy, which deals a lot with the importance of language. So we see a really, really common thread amongst all of these, and this is language. And what we usually don't think about is we're writing code for a living, right? So most of the day we're dealing stuff with one programming language or another. And what does it mean? What does it mean to choose a functional programming language over an object-oriented one, over a procedural one, over what does it mean, Clojure or Haskell or Erlang or whatever. And the goal of the talk that I'm going to give today is hopefully enable you when you next come to read code or write code to wear on a new pair of spectacles that will let you view the decisions that you make in a different light. And the approach that I want to take is through the philosophy of language. Usually what happens when people correlate philosophy and computer science, they usually gravitate towards the realm of philosophy of science. But I'm going to talk about philosophy of language and how it correlates to us writing code. So a big disclaimer, I'm going to go through lots of stuff, and I'm going to do it pretty fast, and I'm only going to skim the surface. I'm not going to teach every one of you how to be a philosopher, philosophy of language, and stuff like that, but I am going to touch on major subjects. For those of you who are well-versed in the subject, my apologies in advance. I'm going to do a big disservice because I'm skipping a lot of stuff, and also I'm doing it with a certain intent. I have a goal in mind, okay? So we'll see what the goal is at the end. Philosophy of language, these are the main principles, the main concepts, and I'm going to give examples in code because that's what we do, right? And by giving examples in code, hopefully you'll see how the philosophy of language and code correlate to one another. So the first principle of philosophy of language is the principle of compositionality. What does it mean? It means that when you speak or write or whatever, there's an order to the sentence. And if you flip stuff around, they can be flipped around, but there's an order of importance. Like even in mathematics, multiplication is higher order than addition or subtraction and stuff like that. The same way is in all languages. Okay, so this is the first principle of compositionality, and you see how it relates directly to our day-to-day job. Second thing is a propositional function. And a propositional function means that I can introduce some unknown, in this case it's an X, and I can later on in my text refer to it. It's really, really common in literature when you introduce something, some unknown word or whatever that no one knows yet, and it gets depicted or given content later on in the story. Usually in the notion of philosophy of language, it has truth value at the end. What does it correlate to on our day-to-day job? Usually with functions that receive some parameters that their value is still unknown, but later on we populate this value with. This is a mind bender. This is like the crux of the matter. Referring expression. The equality sign has been abused in programming languages, right? Usually in regular, imperative, object-oriented, this is an assignment. I'm assigning the value 1 into a variable x. But in the concept of philosophy of language, what I'm trying to do is I'm trying to give a pointer. I'm trying to give a symbol, and it points to something usually in the real world or in the world that as we perceive it. Let me give you an example. If I say the word ball, right, this is the pointer, the word ball, but there can be many different types of ball, right? There can be a basketball and a football and a racquetball, a tennis ball, and blah, 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 blah. So different types of ball. Which type of ball am I referring to? Even if I try to narrow it down, even if I say a basketball, there are many different types of basketball. So what we see here is a very loose connection between the pointer and the pointee. And I think this, where do we see it? We see it with variables in languages that have variables that their value varies over time. And I think that if we look at functional programming languages, the notion of immutability tries to concrete this relation, right? X is a 1, and we can do 1 equals X, and it's the same thing. But on our day-to-day work, on our day-to-day life, language, and the words that we speak often point to a plethora of meaning. There is one language that everything there is self-referential. Nothing points to the outside world. And because of that, it's a pure language. Which language is it? Mathematics, exactly. Mathematics. Why? Because in mathematics, 1 is 1, and that's it. It points only to itself, right? It's the odd child out of all languages. And again, philosophy of language deals with truth-conditional theories. And this is like the direct relation to what we do in everyday Boolean algebra and stuff like that. Well, everything there is exists in philosophy of language. And that sounds a lot like programming, right? We talked about truth conditionals and variables and pointers and stuff like that. And this is how language, the stuff that we do on an everyday basis, talk, write, communicate, send an email, Slack, whatever, this is how it correlates to our day-to-day and to programming. Who is this guy? It's written. This guy is Ludwig Wittgenstein. There's a really nice quote. Does anyone know who said those things about him? So Ludwig Wittgenstein will go a bit, will say who he is and why is he relevant to us. But the quote that you see underneath him is by his teacher, Bertrand Russell. Okay? And if you think about it, it's a really amazing thing for a teacher to say about his student. So how does Ludwig Wittgenstein relate to what I'm trying to present here about philosophy of language? Let's talk a bit about Ludwig Wittgenstein. He taught at Cambridge, right? He wrote primarily in logic, philosophy of mathematics, philosophy of mind, and the philosophy of language. Let's stop here for a minute. Logic, philosophy of mind, mathematics, and language. If he dealt with all these areas, probably there's some common idioms or notions that correlate to each one of them, right? How does mathematics relate to language? How does it relate to cognition, to the philosophy of the mind? How does everything come together? This is what we'll try and speak about here a bit. And he published only one book, the Tractatus Logico-Philosophicus, 1921, 75 pages long. It took me a year to read it at the university. It's a really, really, really hard book to read. And we're going to try to sum up the main principles there. It's worth noting that later on in life, he refuted his earlier work, the same Tractatus. But even nowadays, the Tractatus Logico-Philosophicus is kind of the crux of the matter when people talk about the philosophy of language. So what is the Tractatus? It's his main body of work. And what he tried to do is to bring an almost mathematical approach to how we perceive language and analyze language. All right? The name is Latin for logical philosophical treatise, and it's comprised of 7 main propositions, which we're going to talk about now. The first and the second one. The world is everything that is the case, and what is the case is the existence of a states of affairs. This is the part where you go, and you'll be correct. So when you study philosophy of language, the first lesson, philosophy of language, I go into the room and I see there are a lot of people around me, and the professor comes up and she says, listen, we're going to do some hard stuff, not only today, the entire semester, and your goal is just to delve through it. You don't need to understand everything, just get the general notion, try to embrace the spirit in which it was given, because the philosophical act, which we'll talk about a bit later on, is acting and doing and reading and trying to reason about what you just heard in some other manner, change the way you perceive stuff. So let's try and do that. We don't need to understand everything to the low limit, but we'll try to get the general notion of what Wittgenstein tried to say. I'm doing, again, a huge disservice by summarizing the propositions. But I'm allowed because that's what I do here. All right? So what are the first and second proposition? In essence, what he's trying to say that the world consists of small logical facts which are almost as he liked to call it, logical atomism in direct relation to atoms, right? A word is a single logical atom. All right, up until now, fair enough. We're good. Let's talk about the third proposition. A logical picture of facts is a thought. So the world consists of a totality of interconnected atomic facts. The proposition make a picture of the world. And we cannot say in language what is common in the structure, rather it must be shown. We cannot step outside of the language. So the next evolution, again, mathematics, you have some common numbers or whatever, some common parts, atoms, and then you compose them together. The composing generates something he likes to call a picture of a thought, which is an expression for him, okay? What the Tractatus always states is that one cannot go outside the boundaries of the language. The language is what defines not only itself, but it defines the way we think about stuff. So Wittgenstein was a really strong proponent of the notion that we think in words and languages, and only those that can be expressed via language are those that exist as a thought or a notion. The fourth and fifth proposition, a thought is a proposition with a sense, and a proposition is a truth function of elementary propositions. Again, it means a whole lot, but for our use case, it lays the groundwork for truth tables and truth conditionals. What does it mean when a picture, a connection of logical atoms, coincides along or juxtaposed against another picture of logical atoms? How do they relate to each other? Does it create a truth value, a false value, and stuff like that? The sixth proposition, the general form of a proposition is the general form of a truth function. Later on, he said in the book, he goes and says that any logical sentence can be derived from a series of NOR operations on a totality of atomic proposition. I just found out, like a couple of months ago, that this is in fact the way that compilers are made, right? Everything is going through some NOR gates until they culminate together to create the actual outcome. And this is Philosophy of Language, 1921, right? So what have we learned so far about this? So this is how people come out of the first semester of Philosophy of Language. But we talked and presented some notions, and I'll try to push the envelope towards the realm of what we do in our day-to-day programming. So if we talk about the first and second propositions, which deal with logical atomism, defining the small parts that everything consists of, is like defining symbols, right? I even give examples in closure, the fx1. The third proposition, which deals with combining some logical atomism into a notion, into a thought, can be thought of as in maybe an entire program, but a small, if we look at the micro level, it can be a single function. The fourth and fifth propositions, we deal with truth values and truth tables, are this, conditionals, right? And the sixth proposition, which deals with NOR operations over the entirety of everything, can be seen as function composition. What didn't I mention? How many propositions are there in the Tractatus Logico-Philosophical? 7. There's only 6 here, all right? Maybe we'll talk about the 7th one at the end. So the primary conclusions from Wittgenstein's work, all of these are his quotes, which are really nice. The limits of my language mean the limits of my world. One cannot go outside of the language to express anything else. the boundaries are the language. We think in words, we reason with words, we communicate with words, and our code, the expression there is with words. So the limits of the language is the limits of the world. Pay attention to your nonsense. I put it there because it's always nice. If we spoke a different language, we would perceive a somewhat different world. This is really important for me, right? What happens when we pick programming language A over programming language B? Why do we do it? Maybe because it helps us perceive the world or the problem space in a different manner, right? This is what Wittgenstein really believed in. And again, philosophy is not a theory, but an activity. That means that I'm blabbering here on stage, but at the end, I want you, whenever you go back to work and start writing a new piece of code or reading a new piece of code, I want you to try and look at it in some different manner. Make a conscious decision about the intent that you're giving to the code, the expression that you're trying to relay to other people and to the entirety of the software. It's got a really, really famous paradox. It's called the beetle box, which is really common in software engineering. So a guy catches a beetle, puts it in a box, comes to his friend, they told him, listen, I caught a beetle in the box. And his friend tells him, it's amazing, I also caught a beetle in the box. And he says, yeah, let's compare. He says, mine has 6 legs. And he says, well, mine has 8 legs. Mine is dotted. Well, mine is not dotted, mine has wings. Mine has antennas, mine don't have antennas. And then both of them go, well, we're not talking about the same thing, right? How many times in your day-to-day job you got handed a bug or a task or whatever, and someone told you, well, fix this, do that, and you're like, what is he talking about? So common idioms and common ground to stand upon are really hard to come by. That's why that's why partially we're obsessed with naming stuff, variables, functions, models, libraries. We're obsessed with really defining the problem because, again, we're not dealing purely in mathematics. The world that we're living in has reference from one word to something else, and we're trying to keep this common to each other. And this directly correlates to programming language selection because we ask ourselves the following questions. Can we solve the problem using different languages? If so, why one and not the other? And what do we gain or lose, right? Like the common notion that people in Antarctica or whatever has got 50 different words to depict snow, and if I have to do it in English or whatever, I'm going to use probably lots of words. Maybe some language is more suited in handling a specific problem space than another language. This should be one of the most defining criteria, in my opinion, when selecting a programming language. This is the 7th proposition. That whereof we cannot speak, thereof we must remain silent. It's kind of a joke at the end there, because up until now we always said that we can talk about everything in language, and now we said what we cannot speak of, we must remain silent. But it's almost like the notion, the limits of language, the limits of the world is the limits of the language. And that's it. Thank you. I don't think we have time for questions. Does anyone have a question? Oh, yes, thank you.
Thanks so much for the talk.
Yeah.
I wanted to ask, as far as the bounds of the language, with language being evolving and this sort of amorphous thing, do you think that is only developing more precise words for the same sort of total reality, or do you think there's true possibility for growth of language and thus growth of our world?
The second one. And I think that, to be perfectly honest, that's the reason that there are so many programming languages nowadays, right? If there was some perfect language that can just be enriched and depict everything that we need to deal with, we're probably only write in a single language. But what I'm trying to say that a language carries with it a certain idiom or way of thought. And when we're doing stuff in Lisp, in Clojure, we're thinking in some manner. And when we're doing stuff in JavaScript, God forbid, we're doing stuff in another manner, right? So every language carries its own way of thinking, and I think it's going to evolve even more. Thank you.
Yeah, thank you.